All right, guys, last one for a while, right? Because you got Good Friday on Friday and you're got vacation week coming up. So again, I'll take anything late. That's fine. If you want to work a little bit over the vacation because you didn't quite finish anything, don't sweat it. I'm not out to get you. But again, we're going to wrap up this lesson today. I'm just doing one problem and that's it, which is a 3 by 3 matrix, right? Which is where we left off from last class. So here we go. One practice problem is very similar to the question that I'm going to ask you guys to do, for this lesson. So here we go. We have three compounds, right? We have three things that are all made up of the same three elements, and we're given their atomic weights. So carbon, hydrogen, and oxygen are the only three elements that are in these three things, right? Now, some of them may not have one, and that's okay. But here we go. So let's say I wanted to find the atomic weight of each individual element, right? How are we going to do this with that Cramer's rule thing? And that's what we're going to do. So I'm going to take a look and write three equations out. So I know if I'm looking at glucose, right, I'm going to do this one, say I'll do this one in green. So glucose, I can see that as, all right, so there's 6 carbons plus 12 hydrogens plus 6 oxygens. That's a, oh, not a 0, which might be confusing. But that is going to equal a total atomic weight of 180, right? So that's kind of like my first, not a line, right? But it's my first equation. Now, with a different one, I'm going to write carbon dioxide, which is going to be 1 carbon, right? So 1 carbon plus 2 oxygen, and that's going to equal 44. And if I want to keep them in a row, like if I want to keep this in the line, I could say plus 0H plus 2O. That's fine. It doesn't really make too much of a difference for these. And then I have hydrogen peroxide, which is 2H, no carbons, plus 2O, and that is going to equal 34 for an atomic weight. So how could I break this up into solving each one? And I'm going to use that thing called Cramer's rule. So what I'm going to do first is write that coefficient matrix. I have my system of 3 equations with 3 variables. So I'm going to take the coefficients and say, okay, for my carbons, I have 6, I have 1, and then the bottom one actually has 0 carbons. So we want to put 0 in there. For the hydrogens, I have 12 hydrogens for the first one. I have 0 hydrogens for the second one. And I have 2 hydrogens for the third equation. And then the oxygens, they all have oxygen. So it's 6, and then it's 2, and then it's 2, right? So that's my coefficient matrix. And again, I need to figure out what the determinant of this is. So what I'm going to do is I'm just going to copy the first column over. And I'm going to copy the second column over so that I can get the determinant a little bit easier. And then, all right, I'm going to say, okay, well, 6 times 0 times 2, that's 0. These zeros in here are actually going to be a lifesaver for us. Then I have 12 times 2 times 0. That product is also 0. 6 times 1 times 2 is 12, right? So the only thing, if I added all those up, it's only going to add to 12. And then I'm going to subtract these things going the other way. So 6 times 0 times 0, well, I'll use a different color. 6 times 0 times 0 is 0. Great. 6 times 2 times 2 is 24. So we got 24. And then I have 12 times 1 times 2, which is 24 more. So I have 12 minus what's going to be 48. So my determinant, right, the determinant of this coefficient matrix is going to equal negative 36. And again, that's what's going to go on the denominator for all of these. So I'm going to extend this a little bit. All right, so here we go. Let's say you're going to find them all, but I'm just going to probably do one just for the sake of time. I'm going to find carbon, right? So I'm going to say, okay, well, carbon is going to be equal to the determinant of some 9 by 9 matrix divided by this negative 36, right? Which is the determinant of this guy. So what the numbers that go in here are very similar to this one, but all of the carbon coefficients go away. So the 6, the 1, and the 0 are going to go away, and I'm going to replace them with 180, 44, and 34. So definitely calculator is totally fine. So we have 180 and 44 and 34, right? Didn't really make enough room here, but we'll make do. And then I have 12, 0, and 2 for hydrogen, 12, 0, 2 for hydrogen, and then I have 6, 2, 2 for oxygen. 6, 2, 2 for oxygen. I need to find the determinant of it, so I'm going to repeat these first two columns. So I got 180, 44, 34, and 12, 0, and 2, right? So let's see here. Go back to my highlighter. Say, all right, here we go. I got 180, 0, 2. All right, that product's going to be 0, which is great. 12 times 2 times 34, that's a tricky one. And then 6 times 44 times 2, also tricky. But I have a calculator that I am going to do this. It's basically going to be 0, right? It's going to be 0 plus 816 plus 528, right? Those are the products of each of those. Now, if we're going to go the other way, let's say I'm going to use, right, 6 times 0 times 34. That's going to be 0. 180 times 2 times 2 is going to give me 720. 12 times 44 times 2 is going to give me 1056. So and I did not just do that quickly. I had these written down. So I'm going to take this and I'm going to subtract what is the product of each of those. So the first one was 0, the second one was 720, and the third one was 1056. All right, so if I did all of those numbers out, I would get negative 432, right? That's what the whole thing is going to equal when I did the whole thing out. So divided by that negative 36 would give me an answer of 12. So the atomic weight of carbon is 12. And then you could repeat this for the other elements, right? Replacing middle column or the right column with these same numbers, and get the other ones that way. So I want you to find your own couple compounds for your work today. It's kind of explained on Schoology, and then figure out the atomic weights of each one. Or if you want to find a totally different system of 3 variables and solve it with Cramer's rule, I would say go for it. Like, you have total freedom to do what you want for this assignment. If you can find something on Google that works, I think that's great. Thanks, guys.